Hey there people, we're now going to look at example 2, which we're going to be sketching y equals log. And we'll start by just looking at the basic graph of log base 2 of x. And with that one there, we have an x vertical asymptote at x equals 0. And we're going to have a couple of points, the x-intercept at 1, 0, and another point which we can easily mark there at 2, 1. If we have a look now at our actual function we want to sketch, the transformations are such that we'll have a translation horizontally. That will be 5 units to the right. And we're going to also have a vertical translation of 1 unit up. So it's useful to think about where our points move to, the points that we've got on there, our x-intercept and our other point. So x-intercept at 1, 0 is going to move 5 units to the right, so it's going to become 6 across, and it'll be up 1. Okay, so it'll go to 6, 1. Our other one, which we have at 2, 1, will move to 7, 2. And we'll also find that our vertical asymptote will shift. It's going to go from x equals 0 across to x equals 5. Now we're going to look at finding the x-intercepts. Okay, so obviously with the x-intercepts we let y equals 0 and then solve for x. So 0 equals log base 2 x minus 5 plus 1, and then we can just shift things around. So log base 2 of x minus 5 will equal negative 1, and then change that to an exponential equation. So x minus 5, it will equal 2 to the power of negative 1, which is the same as x minus 5 equals 1/2, and then we can add 5 to both sides. So x equals 5.5. That's our x-intercept. And so we'll sketch now. Okay, so we'll just put in our axes and mark in where our vertical asymptote will be as a first step. So that's at x equals 5. And then we can roughly sketch in our log graph. Okay, our curve, we know how it's going to be shaped. Similar shape to before, there's no reflection. Mark in our x-intercept at 5.5. And we can put in a point or two that we know of. We already know that we've got there at 6, 1, which was the adjusted point from before. And we could also put in another one there at 7, 2 if we want. The main thing is to make sure that we have a minimum of one other point apart from any intercepts and our asymptote. Okay, with that one done, we'll now look at another example, sketching y equals negative log base 3 of x plus 4. So the basic log graph of log base 3 of x, of course, we'll have vertical asymptote at x equals 0, and we'll have a x-intercept at 1, 0, and we'll also have another point on there which would be 3, 1. Just again, it's just a convenient point to locate using our x value the same as the base and the y value being 1. Okay, let's think about now what transformations are taking place. So we're going to have a reflection, first of all, in the x-axis. So that will be flipped, our graph. And we're also going to have a horizontal translation of 4 units to the left, which will mean that our asymptote is going to shift to the left. Okay, so let's think about what's going to happen to the points that we have marked on the basic graph. 1, 0 is going to move Okay, the reflection is not going to change that, but the horizontal translation will. So it's going to move to -3, 0. And so we can see just from that, our x-intercept will be at -3, 0. Our other point, which we have there at 3, 1, is going to shift, okay, to the left 4 units. So that's going to become -1. And because it's reflected in the x-axis, the y value is going to change to -1 from +1. And yeah, let's just write down the vertical asymptote is going to shift to x equals -4. So now we can sketch our graph. First of all, mark in the vertical asymptote. That's going to be at -4, x equals -4. And because it's reflected, we are reversing our curve. We've got our x-intercept there at -3, 0 now. And we've got our point there, which has been moved. We'll mark that in at -1, -1. And it's worthwhile, now that we know that there's a y-intercept, just working out what that y-intercept will be. So we need to let x equal 0 and solve for y, so that we see that y will equal negative log base 3 of -4. And when we mark that in, we'll just leave it as an exact value, okay? Try to avoid putting in decimal values. Decimal values, finding that on your calculator is useful to find out whereabouts it is, but mark it on there as an exact value. Okay, so now we'll look at our last example at y equals 2 times the natural log of x plus 5 minus 3. And again, what we're going to do is just draw the basic graph of log base e of x. Okay, you don't always have to do this. I'm just doing it to start with, just so that you can see how the transformations change things. So we'll just start by drawing our basic graph. So we've got our vertical asymptote at x equals 0 and our basic curve with our x-intercept also. Vertical x-intercept at 1, 0, and another point which we can conveniently mark there at E1. Okay, our transformations. First of all, we've got a dilation factor of 2 in the y direction. We also have a translation of 5 units to the left. And a vertical translation as well, 3 units down. If we were to think about how these points are going to move, our 1, 0 point, the dilation factor of 2 is not going to change anything because 0 times 2 is 0, but we are going to have a change because of the translations. So 1 minus 5 will give us -4, and then 0 minus 3 to give -3. So that's a point that will lie on the curve. Our other point, E1, is going to move, if we think about the dilation factor, that's going to change our y value. And we also need to consider that our y value is changed by the vertical translation as well. So the y value of 1 multiplied by 2 to give 2, and then subtract 3 to give -1. That's our y value, and our x value, E, becomes E minus 5. Our vertical asymptote of x equals 0 is going to shift to the left, so it's going to become x equals -5. So what we can do is we can quickly sketch our graph. And first of all, mark in our asymptote at x equals -5. And then we can draw in our basic curve. And we can see there that we're going to have some x and y intercepts now, which will be different to what we had before. So let's work those out. X-intercept when y equals 0. So we'll have 0 equals 2 times the natural log of x plus 5 minus 3, and then rearranging that, so we have 2 times the natural log of x plus 5 equals positive 3, and then the natural log of x plus 5 will equal 3 over 2. Change this to an exponential equation, so x plus 5 equals e to the power of 3 over 2, and then x will equal e to the 3 over 2 minus 5. And we can mark that in on our graph. And our y-intercept with x equaling 0 will become y equals 2 times natural log of 5 minus 3. And then we'll mark that in with that exact value. Now that's enough, okay? We've got enough points there. We've got our asymptote, we have our x and our y intercepts, and we could, if we wanted, put in those other points that we have, but it's unnecessary. We have enough on there. The important thing is that we have our asymptote and at least 2 points, whether they are the intercepts or not. It doesn't matter. The important thing, if there are intercepts, that we include them.